Good morning, students. Today, once again, I have come with a new topic. Chapter is electrostatics. Topic is capacitor. Today, we will discuss in capacitor like combination, mainly ideal capacitor combination, and energy is stored by it. Means capacitor. So today's date is 16th May 2020. This is subject physics and the class is 12. So I hope you will see the full this video. Then you will get the elementary idea of combination of capacitor as well as how it will store the electrostatics energy. So this is start. First of all, I will just brief you the capacitor. Capacitor actually it is an electrical device which can store the electrostatics energy in the form of potential energy also you can tell. So it is a device which can store the charge as electrostatic energy. So this electrostatics energy will be stored, means you can say it is in the form of potential energy also. So that is a device. And the symbol for capacitor, generally in the circuit, the symbol for capacitor we are writing is that is the exact symbol of the parallel plate capacitor. Capacitor is of many types. There are parallel plate capacitor, mid-coil capacitor, cylindrical capacitor. So there are many types of capacitor. It's available in the market. Since here we are going to discuss the combination of capacitor, that's why I have told a little bit the brief idea of the capacitor. Then let's come to the important points which to be understood in the capacitor, that is capacitance. So capacitance means it is the capacity. It is actually the capacity. It is the capacity up to which capacitor can store the charge in the form of electrostatic energy. So the symbol for capacitance is C, and since the capacitor is known by its capacitance, means in the market if we go to search the capacitor, commercial capacitor, we have to tell its capacitance. So we should know its unit also. So SI unit of it is farad. Okay, it is denoted by F. Now let us see how the capacitance we are writing. This is very simple to understand. The capacitance means as well as the charge is stored inside the capacitor, the potential difference is going to be increases across the capacitor. So if I take an example of parallel plate capacitor, if it is a parallel plate capacitor, so it has two plates. One plate is carrying positive charge and another plate is carrying negative charge. The direction of electric field will be from positive to negative. Since this is connected with positive terminal of the battery and this is connected with negative terminal of the battery. So in this situation, here some potential is going to be generated. The potential, here also the positive potential will be there, here will be the negative potential will be there, and there must be some potential difference. The potential difference is V. It is arises because of the charge is going to be stored inside the capacitor. So as much as the charge is increasing inside the capacitor, the potential difference is also going to be increases. So what we can say, so V actually Q means V is responsible storing of the charge. So what we can say, as the charge is increases, the potential difference is also going to be increases. So this is the proportional sign, we can remove it. So Q can be written as C times V. Students, here why Q is directly proportional to V? This is obvious. Means as much as charge is going to be stored inside the capacitor, that much potential difference is going to be generated. So Q can be written as CV. So Q can be written as CV, where C is a proportional constant. Where C is proportional constant. C is proportional constant, known as capacitance of capacitor. Capacitance of capacitor. This is a brief idea what I told, because it will be useful when I will do the combination of capacitors and the energy stored by the capacitor. So simply C can be written as Q by V. Simply C can be written as Q by V and V can be written as Q by C. So this is the capacitance of the capacitor. And students, there are many other formulas also for the capacitance. So you can understand, you can find this in next topic, means capacitance of a capacitor. There is another topic. In that topic, if you see, means this is the small derivations. In that derivation, you will come to know the value of C. The value of C will be C is epsilon naught A by B, where epsilon naught is permittivity of the medium, A is the area cross section of the plate, and D is the distance between the plates. So this formula you can do by yourself when you see the capacitance of parallel plate capacitor. So I am moving ahead the combination of capacitors, because my target is today the combination of capacitors. So let us see, there are two types of combination of capacitor. There are here combination, I write combination of capacitor. So there are two types of combination. So there are two types of combination. One is series combination, and next is parallel combination. One is series combination. One is series combination and one is parallel combination. So what is series combination and what is parallel combination, and how the effective value of capacitance can be measured in parallel and series combination, that we will do. So let us see first series combination. In the series combination, if a capacitor's positive terminal is connected with negative terminal and negative terminal of another capacitor is connected with positive terminal of another capacitor, then the combination is said to be series combination. It is also known as, you can say, head-to-head connections or one-to-one connections also we can say. Suppose there are three capacitors of different capacitance. This is positive plate, this is negative plate. Another capacitors, this is positive plate, this is negative plate. Another capacitors, this is positive plate and this is negative plate. And it is connected with positive terminal of the battery, and here it is connected with negative terminal of the battery with potential difference. Total potential difference is V. Then suppose this is first capacitance. So first capacitor, you can say this is A, this is B, this is C. So A have two plates, positive and negative. B also will have positive and negative. C also will have positive and negative. So one positive connected with negative terminal and negative terminal is connected with positive terminal. Again positive is connected with negative terminal. Negative is connected with positive terminal, and then positive will be connected with the positive terminal and negative will be connected with the negative terminal. If this type of combination is there, then this combination is known as series combination. So consider here C1 is a capacitance of capacitor A, C2 is a capacitance of capacitor B, and C3 is a capacitance of capacitor C. Then they are connected in series form. Here they are connected in series form. Because one positive terminal is connected with negative of another plate, means another capacitor. Another capacitors, again negative plate is connected with positive plate of the another capacitors, and so on. So this is known as the series combination. So what happens when the charge is going to flow? They get a unidirection, a single direction, means single direction. So everywhere same type of charge is going to be stored in each capacitor because they are connected with the unidirections. So you can say that the potential generated here is suppose V1, here potential generated is suppose V2, and here potential generated is suppose V3. And the resultant potential or the total potential of the combination you can consider V. Means here I am writing capacitance of capacitor A, capacitance of capacitor B, capacitance of capacitor C is equal to C1 is equal to C2 is equal to C3. Potential difference is equal to V1, here is V2 and here is V3, and total potential difference is V, and total charge is C. Let C be the equivalent capacitance of the combination. Combination means series combination. Then if V1 is a V1 is a potential difference of first capacitor, then what will be the value of V1? Since we know that Q is CV, so V is Q by C. So you can write here what Q by C1, here Q by C2, here Q by C3, right? And the total potential means V1 plus V2 plus V3. So I am using this equation as a main equation, suppose 1, and these equations are 2, 3 and 4. Then from all these equations what I can write, so V is equals to Q by C, because then C is equivalent capacitance, so I will write equivalent, and Q is a total charge. It can be written as Q by C1 plus Q by C2 plus Q by C3 from 1, 2, 3 and 4 equations. Now it means now we can find the resultant one, because all you can see in a numerators there are Q is same, so it can be cancelled out. So the final equation we may write 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C. So this is the required expression for equivalent. This is the required expression for equivalent capacitance of the series combination of given capacitors. Suppose if there are n number of capacitors, then simple. So no need to worry here. If there is n number of capacitor, then C 1 by C equivalent will be 1 by C1 plus 1 by C2 plus plus 1 by C3 dot 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 plus 1 by C, and we can write this. Now here what we can see, the equivalent capacitance of the capacitor, how it is going to fluctuating when there are they are in a series combination. So what we can say, the reciprocal of equivalent capacitance of the series combination is equals to the reciprocal of the sum of the reciprocal of the capacitance of the capacitors of or individual capacitors. I will write here the reciprocal of equivalent capacitance of the series combination is equals to the sum of the reciprocal of capacitance of individual capacitor. Now students, then what will happen if if they are in a series combination? So for this, a simple example, suppose there are three capacitors or suppose two capacitors are there. Suppose C1 is 2 and C2 is 4. Then what will happen? Then C equivalent will be 1 by 2 plus 1 by 4. So this 2 to 4 means 4, means here you can write 2 and plus 1 means 3 by 4. C equivalent will be 4 by 3. 4 by 3 is definitely it will be 1.33, right? So the equivalent capacitance of the capacitor is going to be less than the given capacitance of the capacitor. Means the value decreases. Means the value of equivalent capacitance will be decreasing. Means whenever we are combining in series, the value is going to be decreasing. So now let us move on to the parallel combination. So parallel combination means the positive plates of each capacitor is connected with the positive terminal of the battery. Here, second is parallel combination. So for parallel combination means what we can say, the positive plates of each capacitor is connected with positive terminals of the battery and the negative plates of each capacitor is connected with negative terminals of the battery. Then the combination is known as parallel combination. So see, suppose this is one capacitor A, positive plates, negative plates, capacitor B, positive plates, negative plates, capacitor C, positive plates, negative plates, capacitor C. So all are connected with negative terminal here and all are connected with there are three ways to store the charge. That is why what we can say, here will be suppose charge Q1, here is Q2 and here is Q3, since total charge is Q. So what we can say, the capacitance of capacitor A is C1, B for C2 and C for C3. So let us write that. Let us write that. So the capacitance of capacitor A is C1 and potential difference is B. The capacitance of capacitor B is C2 and potential difference is B. The capacitance of capacitor C is C3 and potential difference is V. Total charge across the circuit is equal to Q, and charge across A, charge across B, charge across C is suppose Q1, here Q2, here Q3. So as we know that there is a potential difference V and total charge is Q, and if C equivalent be the equivalent capacitance of the combination then what we can say for Q. So for Q you can write C equivalent times V, and this can be written as Q1 plus Q2 plus Q3, because Q1, Q2, Q3 is coming from Q. And finally you can write here C1 V, C2 V and C3 V, and here is C equivalent V. So V all are common, you can remove it. So CQ is equal to C1 plus C2 plus C3. For n number of charge, C equivalent will be for n number of capacitors, C1 plus C3 plus C4 or C. Yeah, this way you can. So this is the required expression for the equivalent capacitance of the capacitor. Now what I can say that if the capacitors are connecting parallelly, their value is going to be increases. I mean to say the equivalent capacitance of the combination is going to be increases. Like suppose if you give the example, like two capacitor is there, suppose C1 is 2 farad and the C2 is suppose 4 farad, then C is definitely 6 farad. So it is more than 4 and more than 2. So equivalent value is going to be increases. Now, so by knowing this value, how they are increasing and decreasing, here only the advantages are there. In series combination, the main advantage is connecting in series connection is to decrease the values. If in a market suppose the value is not available of the particular capacitors, then what we do? We try to connect it into the series connection. And if there is a value, if we need a value more than the individual capacitance of capacitors, then we will connect it into the parallel connection. So it was the series and parallel connection. Now let us see how it will store the energy. So energy stored by capacitor. Here I will take the example of parallel plate capacitor. So suppose a parallel plate capacitor, the parallel plate capacitors, one plate is having positive charge and this plate is having negative charge. Since this is connected with positive terminal and this is connected with negative terminal, the electric field is acting from positive to negative. Suppose this capacitor have a capacitance is C and the total potential difference can be arises between two plates is V. It means what? The total So it has to store the charge from initial to final state. So initial state I am taking 0, means no charge, first no charge, and then after that gradually the charge is going to increases. Means storing charge may increase from like 0, dq and dot 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 to q. So first small no charge, then a small charge, then q. But in each time the potential difference of the plate will be B, because the maximum potential difference is B and we have to see for the maximum charge. So that's why we are taking the maximum potential difference is B. And as we know that the basic definition of potential V means it is just the W by Q. W by Q means work done per unit charge to move from one terminal to another terminal. But the thing is that here the small charge first it is going to be stored, suppose dq. For a small charge, the same equation can be written for a small charge dq. This equation will be changed. The V will be same, but work done also will be different, and because the charge is also different, so it will be suppose dq. So what we can say, the work done, if we need to find here, I can write W is equal to V dq. Or if you are getting confused from this W means you can put here dw. You can put here dw. So this is the small work. You can say the small work done for storing the charge dq, storing the charge dq. And as we know that if it is the work done, so definitely this is the work done means what? If this much work is done means what? This much energy is stored by the capacitor. How much work is going to done? That much energy is going to be stored. Means how much work is done for the storing the charge? That much energy of the charge. So that much energy of the capacitor. So immediately it can be written in terms of E also. dE also. So I am writing for the total energy E. This dW can be integrated. And integration, the function is here dq, because dq is varying from 0 to q. So here 0 to q, and the integration will be dq from 0 to q. Now, as we know, in terms of the capacitance, the potential difference is q by q. First we can write q by c. So here the value of V can be changed by this. This Q is intermediate charge after dq you can say, or you can write here total intermediate charge Q. Then we may write here Q dq by C. It will be 0 to Q. So now 1 by C is out. And the integration is x dx like, so it will be q square by 2. It will be 0 to q. So the final equation E will be 1 by 2 q square by c. So this is the energy stored by the capacitor. This equation can be changed in the various terms. Like E is 1 by 2 q square by c. Here q is c times v. C times v. Yes, q is c times v. So you can put it here. So E is 1 by 2 c square v square by c. So c cancel. So it will be 1 by 2 cv square. So this is the required. So students, there are many equations is there to understand the energy stored by capacitor, since this equation can be changed in terms of the medium constant also, dielectric constant also. But for this, we have to see the next video is the next topic. Or you can, if you see the reference, you can take the reference as NCRT. As NCRT means you will get the value or you will understand nicely. Thank you so much.